Okay, today's lesson is section 5.6, and it's going to be a very important lesson for really the next couple of lessons following this, because let me just kind of give you an idea of the reason behind today's lesson. Right now we're solving quadratic equations, and you did some of that for homework last night. Well, in tomorrow's lesson and Monday's lesson, it's possible that you're going to come up with something like this. You don't have to write this down if you'll just observe. We might, I'm just going to throw up a random answer here. We might solve a quadratic equation that ends up like this, where we're asked to find the square root of a negative number. And in the real number system, you probably learned in Algebra 1, that is not possible because there is no real number that you could multiply by itself or times itself to get negative 25. So in Algebra 1, your teacher probably said something like, well, that would be undefined in the real number system, which is true. So therefore, we're going to open up a completely new set of numbers, completely different from the real number system, and these are called the complex numbers. And they utilize this new number, this imaginary number, I. So by definition, the number I is the same as, it's equal to, the square root of negative 1. And we get a spin-off truth from that. If you just think about it, if I raise both sides of this equation to the second power to get rid of the radical, then something else becomes true, and that is I squared is equal to the number negative 1. So these two truths, or if you want to call them definitions, they're going to be used, especially this. It's going to be used quite a bit in this lesson as we basically introduce you to the complex numbers so that we can take the next step in the next couple of lessons, simplifying answers that involve the square root of negative numbers. Okay, so that's kind of the reason why we're doing today. So your first set of problems, actually 1 through 10, I can just write this down for you. Problems 1 through 10 are going to look very much like this. You're going to be given the square root of a negative number, and you're going to be asked to simplify it using this number I. So let me just help you out with the first one. I'm going to write this as two radical factors. I'm going to represent the square root of negative 2 as the radical negative 1, square root of negative 1, times the square root of 2. I think you would agree that if I multiplied those two radicals together, I would get the square root of negative 2. So, and I'm not saying you have to do this, but for some people it helps when you're just getting introduced to how do we use the number I to simplify. Well, here I can see the square root of negative 1, which literally is the number I, and I can't simplify the square root of 2 anymore. So my simplified answer is I times the square root of 2. Now theoretically, multiplication is commutative, and I square root of 2 is really the same thing as the square root of 2 times I. I get it. But just for form's sake, so we won't be confused, it's preferred that I not do this, because it might look like the I is underneath the radical. Okay? So when you have I times a radical, we just prefer that you put the imaginary number I in front, so we're not confused. Okay? So I'm going to work through number 2 with you, and then maybe I'll get a volunteer for number 3. For number 2, I'm going to use 3 radical factors. I'm going to use, again, as always for these, I'm going to use the square root of negative 1. But this time I'm going to use the perfect square root radical 4 times the non-perfect square root number 3. And the reason for this, again, your answers tonight have to be in simplified radical form. There is a perfect square root for 4? That's obviously 2. We already know what the square root of -1 is. That's I. So putting it all together in a final answer form, I would have 2I times the square root of 3. Now someone asked me earlier, well, couldn't you have also used the square root of 6 times the square root of 2 also to get the square root of -12? And the answer to that is yes, but does that help me simplify radicals? How come? Okay, there is no perfect square root of 6, right? There is no perfect square root of 2. So the goal is to use a perfect square root number that can be simplified. And that's why we chose to go with 4 times 3. So just a little review of what you learned in Algebra 1 on how to simplify radicals. Anybody want to try number 3? Okay, Thomas?
Would it be the square root of -1 times the square root of 9 times the square root of 4?
Okay, now you could break that up into 2 different radical factors, but as it turns out, 36 is already a perfect square. So you really don't have to break it up into 2 radical factors. What is the square root of 36?
6.
Okay, so put that all together, Thomas, as a final answer, and you would have 6.
Yeah.
6I. And very good. Even though I isn't a variable, variables are letters that could change. I mean, the numbers that could plug in for variables could be different depending on the problem, but I is always the same. I is always the square root of -1. So even though it's not really a variable, we treat it like a variable when we write it. So, you know, if I had the expression 6x, obviously I wouldn't write x 6. So you probably figured that out. So this is my final answer. Thomas got it. Very good. Okay, let's try this. Continuation of what we just did, but now we're asked to write our answer in complex number form. And a complex number, as I showed you on the previous slide, is always written in this form, a plus bi. And my writing is not real good here, but a is the real number part of this. It's just a regular number, and then the number combined with I will always be the second part. And the order of this does matter. Okay, we always want to put the real number part first, and then plus or minus the imaginary part will always follow. Okay, so back like we were doing before, can somebody help me out with simplifying the square root of -28? Anybody want that? Any brave soul? I'll have to call on somebody. Oh, okay, we have a volunteer. It's Mr. Chamberlain. What do you got?
Would it be 6 minus, I guess it'd be -1.
Square root of -1.
Square root of -1
Okay.
times square root of 4.
Good.
And square root of 7.
Awesome. Okay, I'll stay with you. You're doing so well. How would you simplify that?
Would it be 6 minus again? Since 4 is perfect square, 2 I times the square root of 3. I mean 7.
Okay, very good. And it's in this form. The real number part of this complex number is the 6. And then the imaginary part, in this case, it's represented as bi, always follows. And so we're good. That's our final answer. Okay. We're going to try a couple more of these before we move on. Does anybody want problem 2A? Anybody want to take that one? I'm going to get Sam. Can you help me out with simplifying the square root of -18?
9 or -1.
Square root of -1?
9 and 2.
Okay.
What's that?
All right. Now simplify your radicals. That can be
30, 77,
Okay, very good. He went ahead and turned it around because in this case, the real number part of this complex number is 7. So it goes first. The square root of 9 is 3. Square root of negative 1 is I. And then the square root of 2. So you might not think it matters because addition is commutative, but it really does matter that in these problems, your final answer needs to be in that form, A plus BI, A being the real number part. Any questions on that so far? Okay, letter B, anybody want to take it? How about Eli? Can you help us out with letter B?
Be negative 7 times the square root of negative 11 times 11.
You said the square root of
Negative 11 and 9 times the square root of 11.
well, let's break that up into factors like we were doing before. We know it's going to be the square root of negative 1 times the square root of 121. And I think you're thinking the right thing. You notice that this is already a perfect square number. What is the square root of 121? Okay, so that's really just 11. And what is this? Okay, so we put it all together, and we have negative 7 plus 11i. Okay? Everybody good? Before we move on? All right. So I don't think did I give you problem numbers for those? That's 11 through 18. It's what these look like. Problems 11 through 18 will involve this. Okay, problems 19 through 23 are going to ask you to find the absolute value of a complex number. And I've provided you with the formula that is required to do that, but I don't want to just say, here's the formula. I would like to show you, based on your prior knowledge, how this formula is derived. I want you to see where it came from. And I think maybe if you see where it came from, it might help you remember when to use it and how. Okay? So you're not going to have to graph complex numbers tonight on the homework, but you are going to graph them on next Friday's test. So I want to show you real quickly how easy it is we'll just take this letter A, complex number, and I'm leading up to getting to the answer for this, so just bear with me for a second. I want to show you how you can graph this complex number 6 minus 4i on what is known as the complex number plane. Okay, it's very similar to the real number coordinate plane. Each of them have an x-axis. That should be pretty familiar. But this is where it changes. This is where they differ. The real number coordinate plane has a y-axis. The complex number coordinate plane has an I-axis. Okay? So graphing this number 6 minus 4i is really as easy as this. I want you to think of the real number part, the A, like you would the x-coordinate of an ordered pair. Okay, so make sure you get this little graph down because it's going to come in handy for later. So for the number, in this case 6, this part of the complex number, I'm going to go right 6 on the x-axis. Just think of the x-coordinate of an ordered pair. And think of this next number, the B number, negative 4, as the y-coordinate, even though we technically are going down the I-axis. So this dot right here, if this were the complex number plane, this would be the point 6, or the number 6 minus 4i. It literally means go right 6 and down 4. Knowing that instead of a y-axis we have an I. Okay, now somebody raise your hand and tell me, going back to what you learned about absolute value years ago, what were you told that absolute value is in the real number system? What does it mean to find the absolute value? Yeah.
Find out how far a number is from 0.
On the what?
The
The number line. Very good. So Thomas nailed it. It's the distance a number is from 0 on the number line. Well, when you're asked to find the absolute value of a complex number, what they're asking you to do is find the distance that number is from the origin on the complex number plane. So, in other words, the absolute value of this number is this distance. Okay, well, let's see something kind of interesting. If I were to drop a straight line straight down to this point, and if I drew a straight line that way, I would have a right triangle. Okay? And the side opposite the right angle is called the, anybody remember that? Starts with an H. Hypotenuse. Okay? So, in other words, we already know how to find the side known as the hypotenuse. What do we use? Very good. Mr. Chamberlain said the Pythagorean Theorem, which says c squared equals a squared plus b squared. Well, I know that I'm looking for that distance, which is the c of this triangle. Well, how would I find c? I've got c squared, but how do I find just regular c? The square root of both sides. Well, lo and behold, when I do the square root of both sides, I've got the formula that we need. So literally what you're doing when you're looking for the absolute value of a complex number is you're finding the hypotenuse of a right triangle. Okay? So now that we know that, let's utilize our formula, and I'm going to work letter A with you, and then I'll see if we can get somebody to help me with letter B. So to find the absolute value of this complex number, I'm going to use the formula, the square root of 6 squared plus negative 4 squared. Now, a common mistake people make here is putting I in this formula, but I does not go in this formula. Okay, only the number, the real number A, and the number in front of I. Okay, so let's simplify this, and I'll kind of speed up a little bit. Hopefully you see that that's going to be the square root of 52. And we need to simplify. Remember, you always write these in simplest radical form. So let's think of a perfect square number that divides evenly into 52. 4? Okay, so I could rewrite this using the factors radical 4 times radical 13. And now we can simplify further. What would be my final answer? That would be 2 radical 13. So the absolute value of this complex number in simplest radical form. Okay, let me get Mackenzie. Can you help me out with letter B? Okay, square root of negative 2 squared plus 5 squared, and that's 4 plus 25. Okay, and are there any perfect square root numbers that divide evenly into 29? Not counting 1, of course. No, 29 is prime, so we can't simplify the square root of 29, so we're done. Okay, let's take a look at letter C. Maybe Brianna can help us out. What is the A number in letter C? 0. Yeah. And the B number, of course, is 4, so how would you find the absolute value?
4 squared.
Okay, 4 squared, which is,
Square root of 16.
okay, which is
4.
4. And that should make sense to you now that you know what the absolute value means, because where would I plot the number 4i on this plane? Where would it go? 4 places up. It would be sitting right there. Well, how far is that from the origin? 4. And that's what the absolute value of a complex number means. How far away from the origin is it on the complex number plane? Any questions so far? We're doing great on time. All right. Let's see. We've already done graphing. I think you get graphing. Okay, let's talk about the additive inverse. And you're going to do this on 24 through 28. And these will probably take you about 30 seconds total. Well, going back to the real number system, the additive inverse property says if I take a number and I add its inverse to it, I will always get 0. So the purpose of this exercise is you need to come up with the complex number that would be added to the given number that would give you 0. So what would you add to 8i to make it equal 0? Negative 8i. So that would be my answer for letter A. It's as easy as that. Let me get Jessica. Can you give me letter B? What would you add to this complex number? And you can think about each number individually. Awesome. That would be my answer for letter B. And McKinley, what about letter C? Yeah. So you'll breeze through those, no problem. Just showing you that the inverse property of addition applies also to complex numbers. Last slide. Operations, add, subtract, multiply with complex numbers. And this is going to look very familiar to you because it really boils down to when you're adding and subtracting, you're basically combining like terms, just like you did with polynomials in the past. Okay, so let me go to Jordan on letter A. If you were to combine the like terms and just add them together, what would you have? Okay, that would be my answer for letter A. Letter B, let's see, Virginia. Just yeah, you kind of have to be careful with subtraction because you're subtracting 2i. So negative 5 minus 13i. And notice what operation is implied here? Multiplication. So you need to think like you normally did with multiplying two binomials. What method? The FOIL method. Okay? So Lauren, help me out. FOIL method. 8. Do the outer. Negative 10i. Plus 12i. I squared. Now here's where you got to be careful. And I'm afraid next Friday some people are going to lose points right here. Because going all the way back to the beginning of the lesson, I gave you an equation for I squared. What is I squared? Hopefully you got that in your notes. I squared is negative 1. Remember that? So when you see I squared going forward, you've got to replace it with negative 1. You need to substitute negative 1 in place of I squared, which changes, instead of negative 15i squared, it becomes plus 15. Negative 15 times negative 1. Everybody see that? Okay, now let's keep on going combining like terms. So Lauren, get us to a final answer. Did you say 23? Eight plus 15. And we've got it in complex number form, and so that's our final answer. So be careful with I squared. All right, make sure you always substitute -1 for I squared. Okay, that is your assignment. Yes?
Why is I squared 1 or -1?
Well, let me start this.